Hello, this is Mr. Wynn, and this video is about finding equations of lines with parallel and perpendicular slopes. So, slope is the steepness of a line. It is usually explained as rise over run, and that's when we're reading from left to right. The formula for slope is m equals y2 minus y1 over x2 minus x1. You might have heard change in y over change in x's. To use the formula, you have to have 2 points. You label them x1, y1, and x2, y2. You fill in the formula carefully, and then you simplify. So here's an example. Find the slope of the line containing A, which is at -2, -4, and B, which is at 1, 2. Now, yes, you don't need to draw a graph for this. I'll put one there anyways. Notice here's A in quadrant 3, -2, -4, and here's B in quadrant 1, 1, 2. All right, we're going to label the points this way. -2, -4 is x1, y1. 1, 2 is x2, y2. So when you fill in the formula, you get this. y2 is 2 minus y1, which is -4. When you subtract a negative, make sure you put parentheses, because that's going to be adding in a second. And on the bottom, 1 minus -2. So subtracting a negative means adding. So the top's really 2 plus 4. The bottom's really 1 plus 2. That's 6 on top, 3 on bottom. Then always reduce. That's 2. So this has a slope of 2. So y'all learn rise 2, run 1, up 2 over 1, up 2 over 1. All right, notice, if the slope is positive, then the line will go diagonally upwards when reading from left to right. So this line is uphill. Here's another problem. Find the slope of a line that has -7, 5 and -1, 3. Again, no graph necessary, but I drew it here just for visual representation. Here's how we're going to label the points. -7 and 5 is x1, y1. -1, 3 is x2, y2. We fill in the formula. Make sure you use parentheses when you use negatives. Fix any subtracting negative signs, which is adding. Then you simplify, and then always reduce. That's -1 over 3. So this slope is -1/3. So it's down 1 over 3, down 1 over 3, down 1 over 3. And here, notice if the slope is negative, then the line will go diagonally downwards when reading from left to right. So this is a downhill slope. All right, if given a graph but no points, you need to find 2 easily identifiable points and then use a formula. Or you can use a counting rise over run trick. So find the slope of the line below. And I actually use the same graph from the last problem, so show the exact same slopes. So 2 and -1/3. All right, so first, let's say, notice that the line is going upwards. That means our slope has to be positive. It's going uphill. Now I can find any 2 easy points on the graph that are directly on this one count. So here, this looks like a -2, -4, and this looks like 1, 2. I could then label x1, y1, x2, y2, and fill in the formula, but I'm not going to do it this time. I'm going to use the counting rise over run trick. Remember, we read left to right, so pick the leftmost point. So this one, you're going to rise. See how high to go to the one. So I drew this dotted line here. How many spots did I go up? I went up 6. Then from there, how many times am I going to the right? Running. I run over 3. So slope is rise over run. So I rise 6, run 3. We get 2. So same answer as before. This other one, same idea. Notice the graph's going downward, downhill, so it's a negative slope. Can you pick 2 points? Any 2, does not matter. And fill in the formula, or use this rise or run trick. So we start at the leftmost point. Here, we're not rising, we're going down, so it's negative. So down 2. Then we're running over 6. And the run, the x part should always be positive. So rise over run, -2 over 6, reduces to -1/3. All right, horizontal and vertical lines. Horizontal lines always follow the form y equals some number. So it says graph y equals 5, then find the slope. When I see y equals 5, I know it's horizontal, but also I think y is always 5. It can't be anything else. So first one has 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 7, 5, -10, 5. But y must always be 5. Y can't change. That's why it's called a constant line. All right, I'm going to do the rise or run trick. So for these 2 points, I'm starting on the left. Am I rising? Am I going up or down? No. So rise, run. Rise is 0. Am I running? Yeah, I'm going over right 7 units. So 0 divided by 7. Well, 0 divided by number is 0. So slope here is 0. Note that all horizontal lines always have a slope of 0. Vertical lines are kind of similar. They follow the form x equals some number. So graph x equals 2, then find the slope. X equals 2 means x is always 2 no matter what. So here that's 2, 0, 2, 1, 2, 2, 2, 5, 2, 6, 2, -5, 2, -10. But x is always 2. X cannot change. So we still do rise over run. So using these 2 points, let's go to the bottom first. Am I rising? Yes, I'm going up 5. Am I running to the right? No, I'm running 0. Now we have an issue when you divide by 0. You actually cannot divide by 0 in math. All right, there's an error if you use a calculator. So we're going to say it's undefined. Alright, so vertical lines always have a slope of undefined. Alright, parallel lines. Parallel lines never intersect. The slope is always the same. So here's some examples of parallel slopes. If the slope of the first equation, slope 1, so m1 is 5, the slope of the second equation, m2, should be the exact same, 5. The first slope is -2, the second slope should be -2. The first slope is 3 over 7, second slope needs to be 3 over 7. The first slope is 0, second slope needs to be 0. And even the first slope is undefined, the second slope needs to be undefined. As long as they're matching, they're parallel. Here's some pictures. Notice these two lines are parallel, they're never going to cross. These are both vertical lines. They have a slope undefined. It could also be on a graph instead of just being in the middle of the air. These are parallel, they don't ever cross. Here's another example. These are sideways horizontal lines. The slope is 0, but it will never cross. Notation. In this diagram, you can tell that the lines are parallel because it has these arrows on the lines, so I highlight right here. So arrows mean those lines are parallel. And if you don't have a diagram, they can write in words. You can write L is parallel to M, or you can say L with these two vertical lines that are parallel to M. So two vertical lines like bars are the parallel symbol. Perpendicular is similar. Perpendicular lines intersect at a right angle. That means 90 degrees. And the slopes are always opposite reciprocal. Opposite means change the signs. Reciprocal means flip the fraction. So here's some examples of perpendicular slopes. The first slope is 5. I do opposite. So change from positive to negative. Then I flip the fraction. So 5 is really 5 over 1. If I flip it, it will be 1 over 5. So the second slope should be negative 1 over 5. Alright, the first slope is -2. I gotta change it to positive and flip it. So it'll be positive 1 over 2. Because 2 is really 2 over 1. If it's 3 over 7, turns to negative, flip it to 7 over 3. Then 0 over 1 flips to negative 1 over 0, but remember, you can't divide 0, so it's undefined. A lot of people forget that undefined and 0 are actually perpendicular to each other. Here's some examples. Again, it could be on a graph or in the air. And again, this is a vertical undefined slope. There's a horizontal slope of 0. That makes a right angle right here. Notation. In the diagram, you have to see the right angle box. That means 90 degrees. Or if you want to write it, you'd say line AC is perpendicular to line BD, or there's a symbol right here. You say line AC is perpendicular to BD with this perpendicular symbol. It's basically like an upside down T. It's a horizontal line with half a vertical line on it. Alright, now that you know parallel and perpendicular, we can now write equations. To be able to write an equation for a line, you need to know two things. You need to know the slope of the line and one point on the line. Once you have that, there's two formulas. The first one's very famous, you should know it. That is slope-intercept form, y equals mx is b. So m is the slope, b is the y-intercept. The second option is point slope form, y minus y1 equals m times x minus x1. M is still slope, x1, y1 is any point, and it can even be the y-intercept. Alright, so the first one, slope-intercept form, is the quickest, requires no work, but it requires a very specific point that we usually don't get. You're not always going to know what the y-intercept is, so this is very rarely going to be used. The second one is universal. It will always work no matter what, but it requires a little bit of algebra work. This second method would be our go-to form. If you work it out and solve for y, it will actually turn itself into slope-intercept form. So if you distribute and then you move the y1 over, you'll actually get slope-intercept. So slope-intercept form came from point slope form. Alright, let's try an example. Find the equation of a line parallel to y equals 3x plus 7 that passes through the point -3, 4. Here are the steps. You're going to find the slope needed for our final line. We're going to label the point for our final line. Then we're going to plug in m, x1, and y1 into the point slope formula. Alright, so first, since we want a parallel line, our slope must match the original line slope. The original line slope is 3 because this is already mx is b, so you should identify the 3 right away. So it has to be the same, so our slope is going to be 3 as well. Also, to knock on the second step, I'm going to label x1, y1, so -3 is x1, 4 is y1. Then you fill in the formula. Alright, you always leave y and x alone, but when you fill in y1 and x1, make sure you use parentheses or brackets if it's negative. So this will be y minus 4 equals m is 3, parentheses x minus, and x1 is -3. When you subtract a negative, that's really adding, so fix that sign, and then you're done. So that is a perfectly good answer, so you can stop there, unless the problem wants you to keep going and they say answer in slope-intercept form. Then all you have to do is just distribute and solve for y. So let me also do that as well. So if you want slope-intercept form, you're going to distribute the 3. So you get 3x plus 9, then you need to move the 4 over by adding it to get this. So these are the exact same line. This is point slope form, this is slope intercept form. Here I actually know the y-intercept is 13, so I know it crosses the y-axis at 0, 13. Here's another one. Line 1 goes to the points 6, -1, and 11, 3. If line 2 is perpendicular to line 1 and it passes through the point 5, -8, what is the equation of line 2? All right, so exact same steps. So step 1, since we want a perpendicular line, our slope must be opposite reciprocal of the original. But do we know the slope of the original? The answer is no. If we don't, we have to find it. So we have 2 points, so we can do the slope formula. So I'm going to label those 2 points, x1, y1, x2, y2. Fill in the formula. Change in y's or change in x. So 3 minus -1 over 11 minus 6. Remember, just negatively adding, so 3 plus 1 on top. 11 minus 6 is 5. Combine the top, we get 4 or 5. Always check if we reduce, but that's done. Now that's the slope of the first line. Remember, we need opposite reciprocal because we're finding perpendicular. So I'm going to change this from a positive to negative and flip it to 5 over 4. So our m is going to be -5 over 4, and our point that we need for our line would be this 5, -8. Now we have the slope and the point. We use point slope form. Fill it in carefully, and when you subtract -8, that's really adding 8, and we're good. And I'm not asking for point slope intercept form, so we can just leave it like that. Here's the next one. Find the equation perpendicular to the line 2x minus 3y equals 9 that also passes through 8, 10. So same steps, but this form is kind of weird. That's not point slope form or slope intercept form. So if given an equation in a weird format, just solve for y to turn it into slope intercept form. Then it'll be easier to read. So that's my problem. To get y by itself, I'd move the 2x over by subtracting it. I'm also going to put it in front. Then get rid of this negative there to divide. But slope intercept form doesn't have a big fraction. It's split. It's a mx term and a plus b term. So I'm going to divide this into 2 fractions. You can do each numerator over the bottom. So -2x over -3, and then positive 9 over -3. Negative by negative is positive. And then 9 divided by -3 is -3. So when you add -3, it's really just subtracting 3. So this is the exact same equation, but now I see that the slope is 2 over 3, and the y-intercept is -3. All right, now we do the same process from before. We want perpendicular, so we do opposite reciprocal. So opposite reciprocal of 2 over 3 is going to be -3 over 2. And then our point is 8, 10, so I'm going to leave that x1, y1. Fill in the formula, and I get this. There's no sign to fix, so I'll just stop right there. All right, last slide. Now this is an extra topic that's kind of difficult for pre-AP really, but how to find the distance between a point and a line. So first, let's notice when trying to find how far something is away from something, you want to take the shortest path, which is straight to the target. So the path is always perpendicular to the target line. So here's the simple picture. If I have this dot, this point, and this line, what's the fastest way to get from the dot to the line? It's to be straight down. So it says which colored line represents the shortest distance between the point and the line. It's the red line. And that is perpendicular. All right, if you do the blue line, that's longer. If you do the green line, it's longer. And if you know about right triangles, this blue line is hypotenuse, and this green line is hypotenuse. If you have this triangle, the hypotenuse was along the side. All right, so let's try this problem. Find the distance of point A to the line y equals -2x minus 1. And I drew this picture just so you can see. And you're not supposed to this diagonal dotted red line yet. That comes later. So let's talk about the steps first. Again, it's kind of tedious and requires a lot of steps, but try to understand it. Basically, first, you want to get the equation of both perpendicular lines. Once you have that, you're going to find the intersection of the 2 lines where they cross, this dot right here. And that's going to involve a system of equations. You learn in Algebra 1. You got to do substitution or elimination. Then you have to do the distance form between our real starting point, our real point, and that intersection point. All right, so here's the first part, find the equation of both perpendicular lines. Luckily, we have the first one. If we didn't, I'd have to find 2 points and then do the slope formula or do the counting method, rise or run, and then use that slope with one of those 2 points to find the equation. It would be a lot of work. It's actually double the amount of work. All right, so we have to find one. So we already know the slope is -2. Perpendicular means opposite reciprocal, so positive 1 over 2. Here's our point. We fill in the formula, and I get that. But I actually wanted to have y equals, so I'm going to solve for y for slope into form. So I'm going to distribute the 1/2. I'm multiplying everything by 2 to get rid of the fraction, and then I'm going to add 5 over. Notice this is the equation of the dotted line. It's the y before and slope up 1 over 2. All right, step 2, we have to find the intersection. We're going to use the system. We have 2 equations. They're the exact same y, so we have y equal to y. Do substitution. I'm going to solve this. So get rid of the fraction, move x to one side, get x by itself, get negative for x. Then you need to solve for y by plugging it in. So we get negative 2, negative 3, positive, we'll call it b. Then last, find this form from a to b, and you should be able to read this formula. And that's it. Thanks for watching.